All right, so what about this? It says fill in the blank with a simplified expression to write the inverse of the function. And then it wants the domain of the inverse function and then the domain of the original function so that it's invertible. Now what that means is invertible in math means take the inverse of both, right? We want to be able to set up the original function so that it has an inverse, right? Okay, we'll get to that stuff a little bit later. Let's just start at the start here. What's this notation mean, first of all? It's kind of weird. It doesn't mean to the -1 power. What's that mean if we do f seeming like it's raised? Okay, that's inverse, right? That's saying the inverse of the function f of x, right? So let's think about what it means to be an inverse. It's been a while since we've talked about this stuff, but what is, oops, first. So what's it mean to be an inverse? What if I took, for example, let's say that my relation just consists of a couple points. So let's say that my function f of x is just going to be the set of points 2, 4, and 5, 1. So if we graph that, 2, 4 is over 2 and up 4, that's right there. And 5, 1 is over 5 and up 1, that's right there. Okay, what does the inverse of that function look like? Okay, -2, so do I go back, suggestions I go back this way, -2 where? Down 4. Okay, I can see why people would, that's a reasonable thing to guess here, but it has a symmetry, doesn't it? We talked about this. Anybody remember what the symmetry is?
Doesn't it just flip down?
It flips over something, doesn't it? It reflects over something. What's the line of reflection?
X-axis.
It's not the x-axis, it's not the y-axis. The z-axis. It's not the z-axis. Where is the z-axis? The z-axis comes out of the board, right?
Isn't it the
It's not-
origin?
It's something different. It's a little bit awkward. It's not the x-axis and it's not the y-axis. It's actually halfway in between.
Yeah, isn't it that weird slanted line?
It is.
I forgot
It's
what
the
called.
slanted line. It is. It's
Isn't
this
it
line.
x equals y?
Yeah, it's y equals x.
Y equals x.
There it is.
That's
So
so
there's, that's the line of reflection, right? So we're just going to reflect it over that, right? Okay, where do you think the point 2, 4 is going to end up? Where? At 4, 2. It is. It's going to end up at 4, 2.
So you just switch
If I drew this line correctly, I don't know that I necessarily did, but if I did, it's going to end up, let me redraw that orange line. It's not very good. So it should be more like that. Okay, yeah, how about that? So if this point has coordinates 2, 4, then its inverse has to be the point 4, 2. Okay, what about this other point? What about the one that had coordinates 5, 1?
It'd be 1, 5.
It's 1, 5, yeah. So this was 1, 5, and now I'll go over 1 and up 5, and so it's right there, right? And that makes sense. Would you agree those are reflections over that line? If I reflect this blue point over the orange axis, it's going to end up right there. And if I reflect this blue point over that axis, it ends up right there. Agree? Okay, we saw something else important here, though. Oh, I did. You're right. This should have been, okay, so this should have been 5, 1, right? Yeah, 5, 1. There we go. Okay, that's important that we change that too, because what did we see happen here?
So just switch.
We just switched the x and the y, which is what an inverse is. That's really all an inverse is. The inverse of a relation is what you get when you exchange the domain and the range. You switch the x and y values, right? And that gives us this kind of symmetry. Okay, so if that's the case, then how could we go back and maybe think about solving this? Because we had sort of a recipe. There was a process we went through if you were given a function to find its inverse. Remember?
Oh wait, is it those patterns that we got? The a
Yeah.
squared minus b squared?
Nothing that complicated. It's just like a little, well, I'll get you started. Here was step one. Step one was we took the original function and we wrote it with a y instead of an f of x. So we wrote this as y equals x squared minus
Did you
6.
just solve for x?
Now what'd we do? Okay, yeah. Now the book would say you solve for x and then you flip. But I prefer, the way I kind of showed you was instead of that, let's go ahead, if we want to find the inverse, let's flip x and y, because that's what an inverse does, right? We're going to exchange the x and y and then solve for the new y, because that'll be the inverse, right? So step 2 was we're going to write this as x equals y squared minus 6. I'm going to flip that around so the y is on the left instead. Same thing though, right? And now step 3 is solve for the new y. So what are the steps in order? Now let's think about this. If I want to solve or isolate a variable, how do I use order of operations? What do I do? I've got PEMDAS.
Reverse it.
I reverse it. I go bottom up, don't I? So if we're trying to solve, if we're isolating or solving, we go bottoms up. So the first step is, do we need to add or subtract anything to get that y by itself? I'd add 6, wouldn't I? Add 6 to both sides, and then that's going to give me, that's going to give me y squared equals x plus 6. So we can cross that step off. There's nothing to multiply or divide, is there? Right? You can cross that step off, but then we get up to exponents. Okay, this is, remember how we did this. How do we undo squaring something?
You do the square root.
Oh, square rooted, I'm here, right? We square root it, right? Okay, so if I square root both sides, what's that going to do? So I'm going to take the square root of x squared, or y squared, and the square root of x plus 6. And if I square root a squared, it undoes each other, right? Okay, but there was one tricky thing about this, remember. I end up with y equals, what do I have to do if I square root both sides? Do you remember? If I'm solving an equation and I square root both sides. Like for example, if we took, and we'll do this on this assignment, and this is actually pretty easy compared to this. What if I have the equation x squared equals 4, right? Clear back in module 3, we said that we could isolate a variable by just, or if we can point to a single variable, we can isolate it. And with stuff like this, we had to undo the square by square rooting, but there was one really important step there that's easy to forget. Does x just equal 2?
No.
No.
Plus or minus.
Plus or minus. Yeah, it's plus or minus, exactly. So if we're taking a square root, or it turns out any even root of both sides, we have to put that plus or minus in there, and it makes sense because negative 2 squared is also 4, isn't it? Right? So we have to do the same thing here. Okay, we have to go back up to this step right here, and if I square root both sides, I'm going to get y equals plus or minus the square root of x plus 6. Okay, but let's look at why that's the case. Let's think about why that's the case. So let's look at a graph maybe of the original function. So the original function was f of x equals x squared minus 6. Okay, so I'm just going to do a little sketch of that. X squared minus 6. Okay, that's a quadratic function, right? That's a parabola. Everybody agree?
Mm-hmm.
What are the values of h and k? It's been a little while, right? But if I were to write this, if I were to write a parabola as a quadratic equation, and I want to put it in the standard form that's going to allow me to see what h and k are. Remember, it just looked like this. We just compared it to a times the quantity x minus h squared plus k, right? Where h and k are the coordinates of what? Well, no, this isn't a circle,
Y
right?
and X and Y,
Those are the coordinates of where on the parabola?
the vertex.
The vertex, right? Those are the vertex. Remember this? And what does A tell us?
It's just the,
Okay, yeah, if A is positive, it's opening up, right? If it's negative, it opens down. And it tells us how much the function's being stretched, right? So if we look at remember this stuff?
Yeah.
It's been a while. Okay, so if we go back up here to our blue f of x then, we compare it to the standard form. What's A? What's being multiplied by x squared? 1. Okay, so we can see that A is 1 for us, right? What's H? No.
No.
Positive 0.
It's 0. Who said 0? Who said 0? How come? You're right. How come, Gage? Why is it 0? H is what's being subtracted from x inside the square, right? So isn't this the same thing as x minus 0 squared? Right? You see what I'm saying? If I plugged in a value of 0 there, x minus 0 is just x, and so that would give me x squared, right? So h is 0. And then finally, what's k? Negative 6. That's just the number that's added on the end, right? So k equals negative 6. So all we've got then is, we've got a parabola. 1, 2, 3, 4, 5, 6. We've just, it's negative 6 though, isn't it? So we've got this vertex down here at 0, negative 6, and this parabola is just going to open up, right? Okay. And it's not stretched, so it goes over 1 and up 1, back 1 and up 1. So it looks like that, right? Okay, so if I want to find its inverse, which we did, the inverse was the function y equals plus or minus the square root of x plus 6. Okay, so let's write that. Here's the inverse. The inverse function is plus or minus the square root of x plus 6. Okay, what's that going to look like? Well, let's put phones away, please. I don't want to see any phones out. So we don't necessarily know yet what a square root function looks like. We're going to know in Module 11, we're going to do a lot of graphing of square roots and cube roots, and it's easy. But for now, what we could do is we could reflect this thing over the line y equals x, because this is going to be the inverse of that, correct? Everybody agree? Okay. So let's graph that line. Here's the line y equals x, and we have to reflect this thing over that. That's kind of hard to do. It's hard to reflect something over a diagonal line. So if you remember, I showed you a trick. There's a trick for this. If you want to reflect something over the line y equals x, instead you can do two things. You could rotate 90 degrees counterclockwise and then reflect over the y-axis, right?
Or can't you
Remember
just
talking
flip
about
over
that?
the intersections?
Well, you could. You could just flip it over the intersections also. And if you're comfortable doing that, that's fine. But we could also do it this way. We could rotate the thing 90 degrees, so it's going to look like there's going to be the rotated parabola. And then I'm going to take this whole thing. Step 2 is I'm going to flip it over the y-axis, right? And so wouldn't I end up then with something like, it's not, this is pretty bad. I'm not a very good artist, as you well know by now. But something like that. Everybody agree? Okay, so we started with the blue, dark blue, and we got the red, right? This is the graph of plus or minus the square root of x plus 6. Well, okay, what's the plus or minus for? The math gods are pretty smart. When they put the plus or minus in there, they put it in there for a reason. Is there something wrong with that red graph? Is it a function?
Mm-hmm.
It's not. You're right. How come?
not linear.
Well, it doesn't have to be linear, but what's going on? The vertical line test. It fails the vertical line test, doesn't it? Right? If we draw a vertical line through this function, we can find places where the vertical line intersects the graph in more than one place. So it fails the vertical line test, doesn't it? Right? Okay, so it's not a function. And so the math gods, in their wisdom, they did something really smart here. The math gods, they made the answer plus or minus the square root of x plus 6. If we take the plus version, and I'm going to turn the graph green for the positive square root function, that ends up being just the top half of this sideways parabola. That's the green part, right? Let's make the other one purple. Okay? The minus part is going to be purple. Well, that's just the bottom half of the parabola. Okay? Separately, they're fine. If I just took the green one by itself and covered the bottom one up, it's a function. It passes the vertical line test, doesn't it? Everybody agree? So really then, when we get this answer of plus or minus the square root of x plus 6, if we want this to be a function, we can only keep half of it. Well, which half do you suppose we keep?
Top.
The top half. The primary or principal square root's always the positive one. So let's get rid of this bottom one and just keep the positive one. So we're just going to erase. We'll just erase that bottom one and keep the top one. Okay, but here's the problem then. That top half of the sideways parabola only matches up with a part of the original parabola, doesn't it? Right? Which part? Which part of that blue parabola is going to map onto the red one? See what I'm saying? Go ahead. The right part is, isn't it? Right. This is, because the vertex of the sideways parabola is right there. Agreed? So here's the vertex of the sideways one. There's the vertex of the vertical one. Well, the right part is the one that's going to reflect over and make the top of the sideways one. And so we have to go back and erase part of that one also. See what I'm saying? This one has to get erased. So now we've got a one-to-one correspondence. If I redraw this thing, because that's kind of messy, it would just look like this. We had, that was the right side of the original parabola, and here's what we got back from that. There's the left side. And those fold over this line, don't they? See what I'm saying? Okay, so then what's the domain of this function? What do you think? If we go back to this picture right here, Caitlin, what's going to be the domain? We said that this guy started at, we had this vertex down here. I never wrote down the coordinates, but didn't we say that h was 0 and k was -6? So the coordinates of the vertex are 0, -6. Well, then what does that make the vertex of the red parabola?
-6, 0.
Yeah, -6, 0, doesn't it? Right? Okay, so -6, 0, right? You get that? Okay, so then what's the domain of the red parabola going to be? What are the x values that are graphed? Well, it's going to be all the x values, what? How, -6 is important. The x value of that point is -6. Would the x value of -5 be on the red parabola? It would. Would -5.5?
Yes.
Yeah. Would -7?
No.
No. So what's that domain going to look like then?
It's gonna be. Oh, is it gonna have the bracket?
Okay, one way to say it. So if we want to look at the domain of this function right here, the domain would be all values.
In front of -6.
So it's going to be greater than -6, right? So -6 on up to infinity. Agreed? Right? Okay, good. What's the domain of the blue function? We can only keep the right half of it, can't
Gonna
we?
be bracket 0 and then
Okay, yeah, the domain of this one is gonna be all values greater than, x can only be greater than or equal to 0, right? Everybody see that? Okay, if we go back and look on this picture right here, this is, let's look at the red domain and the red range. The domain of the red function we said was x is greater than or equal to -6. For the blue function, if we're going to calculate the domain and the range, do that for both. What do you notice about the range of this function? It's starting at the point -6, 0, and we're only going to pick y values above that one, right? So would you agree that the range is going to be all y values greater than or equal to 0? Because the y values start at 0 and just go up. Agreed? What about down here? We said that the domain was all values to the right of 0, including 0. So x is greater than or equal to 0. What's the range going to be for the blue function? If it's starting at the point -6, 0, it's going to be all the y values above that, right? So y is greater than or equal to -6. What do you notice about those domains and
It
ranges?
means 0, -6. For that blue one.
For which one?
The blue.
Oh, yeah, 0, -6. You're right. Yep. Yep. 0. What do you notice about these? What do you notice about the domains and the ranges of the
They're just
function and its
flipped.
inverse?
Backwards.
They're flipped, right? Which is what we said, isn't it? X's and Y's get flipped. So the original domain of the blue function is becoming the range of the inverse, right? And the range of the original function is becoming the domain of the inverse, right?
So you just have to find one answer and then flip it.
Exactly. So really all you'd have to do on this problem is just look at the original parabola, right? I could have just done this. I could have said, okay, if this is the original parabola, I know that the domain is only going to be all the values to the right of the vertex, and the range is going to be all the values above the vertex, because it opens up, right? Make sense? So then the range and the domain of the other function, the inverse, are just going to have to be the flip of that, right? You get that?
Yeah.
So you try one. Prove it to me that you get this. You guys try one of these. Try this one.
You have to
Yep.
graph it.
You don't really have to. Yes, you may. Okay, try this one. Okay, try that. See it. Try that. Try that on your own. Quick. Get your notebooks out and try that. So I want to know what's the inverse function, what's the domain of the inverse, and what's the domain of the original if we want there to be a one-to-one correspondence, so they reflect onto each other. Okay? The first part's really not a big deal. What's our recipe again if I want to find an inverse? First step is,
Switch y to x.
okay, right, write it in terms of y. Next step is switch y and x. Last step,
Order of operations.
yeah, reverse order of operations and solve for y. Solve for the new y, and that's the answer, right? That's the answer to part one. Okay, but what I want to know is what's going to be, what's the rest of this stuff? I want to know what's the domain of the inverse and the domain of the function, right? Okay, what'd you guys get for the inverse? What'd you get?
Positive. Well,
I mean, so what is this function going to be?
plus or minus square root of x plus 10. Or
Okay, good,
square-
square root of x, and does everybody get that? We all got that part? And honestly, that's probably the hardest part. Because we're gonna see here in a second, we got a pretty easy shortcut to get the other two parts. So yeah, we would start off by saying y equals x squared minus 10. Now we're gonna switch the x and the y. I'm gonna change sides of the equation too, so we're gonna get y squared minus 10 equals x. So what are the two steps in order to get the x by itself? Or the y by itself, sorry.
Plus 10 on both sides.
Add 10 and then
Square root.
square root. Okay, good. So we get y equals the square root
But you put
of
plus
x plus
or-
10, right?
Plus or minus.
Plus or minus. But we're not going to need the plus or minus because we can only keep one of them, right? We can only keep the plus one, right? So the answer to part one is
The positive.
the square root of x plus 10. If we want to make it a function, which we do, we can only keep half of that, or it'll
So
violate
you
the
can
vertical
never
line
use a
test.
negative, it's always positive.
Right, it's gonna be the positive one, good. Okay, but now what? So you tell me real quick, for this original function, I wanna know what are h and k? What are h and k?
Isn't it?
What's h?
0.
0, because nothing is being subtracted from x inside the square, right? What's k?
Negative 10.
Okay, and the other thing we need to know is, does this thing open up or down? What's a? 1, so it's positive, so would you agree it opens up?
Yeah.
Like that? Okay then, so if that's true, let's look at the original function. What's going to be the domain? If the x-coordinate of the vertex is at 0, what's the domain going to be? I only want the parts to the right of that, don't I? So what's that going to be? 0 to infinity, right? So this is going to be x is greater than or equal to 0, right? From that 0. Agreed? Okay, what about the range? Justine, what's the range going to be? If we know that the vertex is at 0, negative 10, and it opens up, what's the range? What can you tell me about the y values? Greater than or equal to negative 10, isn't it? Because they're going to go up from negative 10. So y is greater than or equal to negative 10. Good, so we got the first part was just this. Square root of x plus 10. The domain of the inverse, okay, the domain of the function, part 3 was x is greater than or equal to 0. What's going to be the domain of the inverse? How can I get that from this information? Which one of those is going to become the domain of the inverse?
Y. The y is
Yeah,
greater than-
because we're going to flip x and y, right? So this one is telling us that for the inverse, the domain is going to become, instead of a y, that becomes an x is greater than or equal to negative 10,
So wait,
right?
how do you know x is greater or equal than 0? Because
Because we're only going to take, if we want this function to have an inverse that's a function, I can only keep the right half of it, right? See what I'm saying? Okay? And so that means we can only keep the part that's greater than or equal to the x value of the vertex, which is 0, right? Does that make sense? Okay? So then finally we end up down here with the range of the original one tells us that the domain of the inverse is x is greater than or equal to negative 10. You get it? See how that works? Okay. How could we have predicted? I just have one more question for you, and then we'll be out of here. If you get this, you guys, you'll have all this stuff down, which is good. How could I have predicted from the beginning that this function, let's just take an easier one. Let's just take f of x equals x squared. Let's take an easier one. If I turn that sideways, isn't it just going to look like this? How could I have predicted that my inverse was going to violate the vertical line test? What about that original function could have told me that? What do you think? Compare that to this situation. What if the original function is x cubed?
because it's squared.
okay?
And so,
So that means the inverse is just gonna end up looking like that, but this time the inverse is fine, isn't it? Right? If I set this equal to y and I switch them, I'm just gonna end up with the inverse function in this case equals the cube root of x. I don't have to have a plus or minus this time, because isn't the red one okay? It never violates the vertical line test, right? You get that? Okay, but what about this quadratic one? What about that blue shape told me it was going to violate the vertical line
because
test?
it's a parabola.
Yeah, but what about the parabola? Is there a different test I could have done on the parabola that would have told me that its inverse is gonna violate the vertical line test? Brandon, look up here. Don't shut down quite yet. We got one more minute, and this is important, and then we're good. How did I get this vertical line from the blue parabola?
You just went 90 degrees.
If I were to reflect this thing over, here's another way to think about it. If I were to reflect that vertical line that goes with the red parabola over the line y equals x, what are we gonna end up with? A horizontal line. You get that? If the original function violates the horizontal line test, it's still a function, right? But we know that if it violates the horizontal line test, its inverse is gonna violate the vertical line test, right? Does that make sense? So whenever you see a function that violates the horizontal line test, you gotta take off there. Go ahead. Then you know guaranteed you're gonna have a situation like this where I'm gonna get a plus or minus in it, because I'm gonna have to split up the inverse, right? Does that make sense?
Yeah.
Okay. All right, we'll pick this up. I'm gonna be gone 7th period tomorrow for a track meet, but we'll finish this up on Friday, and then you'll have some assignments you can work on a little bit of break. All right.
So